Hello friends, I welcome you all to our channel Board and Beyond. So friends, what we have seen till now is that we have done all the exercise problems from your NCERT textbook on the chapter circles, and then we have also solved the previous 10 years examination problems on the chapter circles, right? So friends, this video is dedicated to save your time, right? So this video is basically having some advanced concepts and advanced theorems which will actually save your time when you are taking up the exam if the question appears whatever I am going to take it up today, right? Something of that sort, similar to that, right? So at the end of this session I am going to make announcement, okay? So be there with me till then, okay? So friends, these are the things that we are going to learn today, right? And to name them, we will understand what is a tangent chord theorem, right? Today we are going to understand that today, okay? Once you have learnt that, you can revisit the problems which you have in your textbooks and then see how easily you can solve them, right? We will also understand tangent secant theorem, okay? We will understand how many common tangents can be drawn which is touching the two circles, right? Okay, when they are in I mean to say different shapes and different coordinates or different places, right? Okay, what is a cyclic quadrilateral? We will understand this also in very brief. What is a cyclic quadrilateral and what are the properties of a cyclic quadrilateral, right? So this we are going to understand, and types of angle in different segments, okay? So friends, these are the things which actually will help you reduce your time, okay, during the examination. So let's start with the first one, right? Okay, so first one says that tangent chord theorem, okay? So let me just first give you a brief how it is, what is a tangent chord theorem, right? So friends, let's take it up one. Let's say there is a circle, right? So this says that, let's say there is a tangent drawn at this point, that is point P, let us say, right? 1 second, or you can, okay, for better understanding, let me draw it reverse, right? So that you can grasp it well. Let's say this is the circle, friends, right? I draw a tangent here, okay, and I draw a chord here, okay. So let's say this is P, this is let's say T, that's okay, T, this is P, so let's call it as Q. So friends, what this theorem says that, let's complete it. P, Q, let's call it as R. So this theorem says that, as per this theorem, angle P let's take S. So angle S, P, Q is equal to angle Q, R, P. So this is the theorem. So if you want a statement for this, okay, I'll give you the statement. Angle made by a tangent and a chord inside the circle at the point of contact is equal to angle in the remaining area of the circle. Now, what do you mean by remaining area? See, whenever I draw this chord QP, okay, this chord actually divides the circle, okay, into two parts, not equal parts, sorry, two parts. One is your this segment and one is the remaining segment, right? So what they say is that angle made by tangent and a chord at the point of contact, that is this angle, is equal to any angle subtended by this chord in the alternate segment. You are getting it? So this is equal to this, or sorry, This is R1. So friends, today we have seen that angle subtended by a chord and an arc in the same segment is always equal, right? So very well we can say that QR dash P is also equal to QRP. So for a moment today we are going to prove that angle SPQ is equal to angle QRP, right? So let's try proving it, friends. So what do? We take the center of the circle, do a small construction and then join this, right? I drop a perpendicular also, okay? Now let's call this angle as A and this angle as B, right? So I am naming this angle as angle A, right? And this angle as angle B, right friends? Now let's call this angle as X. What is X? X is nothing but QP, and let's call it as O. O is the center of the circle. So proof. Let angle SPQ is equal to A and angle QRP is equal to angle B and angle QPO is equal to angle X. Right friends? So these are the assumptions that we have made. Assumption in the sense these are the notations that we are going to use further. Right? Now friends, as per the theorem, we all know that a tangent, okay, and the angle made between the tangent and the line segment joining the center of the circle to the point of contact is always 90 degrees. This we have seen already. So I am taking this forward, right? So angle A plus X, so angle A plus angle X should be equal to 90 degrees, right friends? We have already studied this plus this, because this is a line joining the center of the circle and the point of contact, right? So this implies that angle A is equal to 90 degree minus angle X. Let's call it 1 and leave it there, right? Next, one more thing friends, angle we have T, let's call it as A. So AOX and angle AOP is equal to Y. This also we are making an assumption or making a notation, right? So now friends, what happens? See this triangle OAP, in triangle OAP, okay, what happens is angle X plus angle Y plus this will be 90 degrees, right friends? OAP will be 90 degrees, okay? So plus 90 degrees is equal to 180 degrees, right? This is what? This is sum of all the angles of a triangle is equal to 180 degrees. We all know this, right? This is a well-known fact. So there is no problem in this. So now what we can do here friends is that angle X plus Y is equal to 90 degrees. This implies angle X plus angle Y is equal to 90 degrees, right? Which can also be written as angle Y is equal to 90 degrees minus angle X. Let's call it as 2, right? So we have got equation number 1, we have got equation number 2. Correct friends? Now see, right hand side of equation number 1 and 2 are same. So left hand side should also be the same. Correct? So from 1 and 2, what happens? Angle A is equal to angle Y. This is what we get, equating the two, right? So angle A is equal to angle Y, or let me just write it completely and then arrive to this it's not a problem. So angle A is equal to angle Y. This is okay, right? I hope you understand this, right? I do not have to write everything. Writing this is equal to this and then cancelling it out doesn't matter, right? So angle A is equal to angle Y. Now this angle is equal to this angle, friends. Now just remember the last class, right? What did we study? That angle B will be half of the angle QOP, right? So I have already told you that angle subtended by a chord at the center is double the angle subtended by the same chord in the same segment anywhere else, right? You remember a circle where I drew something like this, just to recollect, something like this. This is center of the circle. I joined it like this, and so all these angles, friend, 1, 2, 3, 4, 5, 6, all these angles will be half of this angle, right? So this is what one of the theorem says. So we can write angle Y is equal to angle B now. Can we say that? Is it okay or not okay to you? Okay. Or else we can take up one more step. So twice angle A is equal to twice angle Y, right? Twice angle A is equal to twice angle Y. What I have done is that I have multiplied 2 across the equation, right? This also suggests that twice angle A is equal to twice angle B, right? Which also suggests that angle A is equal to angle B. This is what was to be proved, right? So hence proved. This is getting covered? Yeah. So hence proved, right? So we will be going further. We will be using this. Okay, this is a tangent chord theorem in our solving of the problems. Now, with this understanding, you can revisit some of the problems which are available in your textbooks. Right? See how fast you can do that. Good. Okay. So let's move to the next one, friends, which says an tangent secant theorem. Right? This probably has not been taught to you so far because it doesn't feature anywhere, but being in 10th standard, I think this is important. We should know that, right? So let's move on to tangent secant theorem. What does it say? So of course there is a tangent involved and there is a secant involved in this, right, friends? Let us try to understand tangent secant theorem, which says that let's say this is a circle, right? I draw a tangent, right? Let's call it as P, call it as T, and from this point I draw a secant to a circle, right? Let's call it as, let's join this and this. So let's P, Q, R. Right, friends? Now this theorem says that PT square is equal to RT into TQ. Right? So this theorem says like this. Now how to give a statement to this theorem? Square of a tangent to a circle is equal to, okay, is equal to part of the secant which is lying outside the circle, okay, into the total secant length till the end of the circle, right? So this is how you can give the statement. Only thing is that this secant and the tangent has to start from the same point, friends. They cannot start from the different point, right? That's the condition. Now let's try solving it, friends. Okay, so let's call this as angle 1 and this as angle 2. Okay, so let's try to prove it. So angle 1 is equal to angle 2. Before that, let me write which triangle I am considering here so that there is no confusion later on. So in triangle PTR and triangle PTQ. So these are the two triangles that I am considering, PTR and PTQ, right friends? Now in this, angle 1 is equal to angle 2. Why? Just now we proved it. You remember? Just now we proved this is a tangent and this is a chord. So angle made by the tangent and the chord is equal to angle made by the same chord in the remaining part of the circle, right? That is equal to 2. I hope you remember it. Just now we did it, right? And angle T is common for them. Angle T is equal to angle T. Common for both the triangles, right? This and this. Now with these two angles being same, we can prove one is similar to another, right? We will write it. So triangle PTR is similar to triangle. Now I have taken P, so P is equal to Q. So let me come back to Q. Triangle Q, T is common, right? And P, right? So once we have proved this similarity, so this will give us what? This will give us PT. We'll write the ratios. PT by QT is equal to TR. PT I have taken, so TR divided by TP. Right, friends? So there is one more this thing which I will not take. So now do a cross multiplication. So after cross multiplication, this into this is nothing but TP square is equal to TR into QT. Look at the result. Is it the same? Yeah. So this is one more important theorem, which being in 10th standard, I think it is very, very important that we should know this, right? Okay. So just thought of taking this. This is basically a theorem which will save a lot of time for you. If you don't trust me, you can try the problems which are available in your textbooks. Okay. Let's move forward. What is that we need to do now? Common tangents in different scenarios. Okay. Pretty easy one. How many common tangents can we draw? Okay. So the first thing, friends, if there is only one circle, how many common tangents that you can draw? So there is no point of common tangents here because there are no two circles. Two circles are not there. So one circle can have multiple tangents. No problem. Right? Now let us say there are two circles and both are concentric, something like this. Right? Center is same. How many common tangents can you draw for these two circles? Right? We cannot actually draw even one common tangent because a tangent to one like this will not touch the second circle, and tangent to like second circle like this will become a secant or a chord for the other circle. So if two circles are concentrics, we will not have a common tangent. Right? Okay. Next, let us say like concentrics we have seen. Now let's say two circles which are touching each other from inside, something like this, friends. Okay, so we can have only one common tangent like this. Rest there is no possibility. Two circles which are touching each other from outside. Two circles touching each other from outside. So one common tangent will be this, friends. One will be this, and there will be one more. Please mind it. Like this. So we are going to have three common tangents when two circles are touching each other from outside, right? Now two circles not touching but in the same plane, something like this. One circle, second circle, they are not touching each other but they are in the same plane. That is what is given, right? So one common tangent is like this, second common tangent is like this, third common tangent is like this, Fourth common tangent is like this, right? So we can have 4 common tangents when 2 circles are there which are not touching each other but in the same plane. Same plane, being in the same plane is very important, friends. If they are not in the same plane, you cannot have a common tangent at all in between these 2 circles, right? One more thing is, this is in the same plane. If it is in the if it is not in the same plane, we cannot have a common tangent, right? Now 2 circles intersecting each other like this. They have intersected. Now the common number of common tangents will be 1 and 2. That's it. It will not be beyond, because I cannot draw. I will draw here, this becomes a secant to this. I draw here, this becomes a secant to this. Correct? So it will have 2 common tangents. So important concept we have just covered in some 2-3 minutes. Right, friends? Sometimes this appears in examination for 1 mark problem or MCQ, multiple choice questions, right? Okay. Now comes cyclic quadrilateral and its properties. So friends, what is a cyclic quadrilateral? So any quadrilateral which is fit inside a circle is called a cyclic quadrilateral. For example, the shape can be multiple, it can have multiple shapes. Let us say this is a circle, friends, right? Let's say this is a quadrilateral ABCD, A, B, C and D, right? This is a cyclic quadrilateral because it has been fit inside a circle. Okay. Now the first property of cyclic quadrilateral says that if I extend any one of the line, let's say I extend BC to E, right? So this angle made here, that is your DCE, angle DCE will be equal to angle BAD. Always. That means the angle made by this extending a line will be equal to the opposite interior angle. This opposite interior angle I am talking about. I am not talking about this, I am not talking about this. When you extend this further, this will be equal to this. 1 will be equal to 2. When you extend this, let us say you extend this further, this angle will be equal to this angle. You are getting my point? Right? If you extend this angle will be equal to this angle. You are getting my point, friends? Right? It is something like this. Right? And another important concept here, friends, that let me call it as this is 1, 2, 3, 4 and 5. Let me write slightly bigger, 5. So now friends, what happens is always in a cyclic quadrilateral, sum of the opposite interior angles are always equal to 180, or they are supplementing each other. They are supplementary angles. Something like this. Angle 3 plus angle 4 is always equal to 180 degrees, right? Whatever shape may be the cyclic quadrilateral, that doesn't matter. Angle 2 plus 5, angle 2 plus angle 5 is again 180 degrees, whatever may be the shape and size of the cyclic quadrilateral. So in in a circle you can fit in a rectangle, you can fit in a square, you can fit in a trapezium, right? All this is possible, right? So some of you may be thinking how to fit a trapezium here. So take this chord slightly lesser in length, take this bigger. You have fitted a trapezium inside, right? So this is how it is. Moving on to the next type of angles in different segment. Okay. So what we will do, friends, we will just take a circle and divide it into 2 segments with a chord, right? So we can understand it very easily, right? So let's say this is the circle. I take a chord here. This chord AP has divided the circle into 2 segments. This is called minor and this is called major. Of course, segment, right? So what I mean to say here is that angle in a major segment is always an acute angle, like this. This is an acute angle. Acute angle. Right? He has come double times. Okay, acute angle. Anywhere. Doesn't matter. You have to draw there only. So angle in major segment is an acute. So let's divide this segment. So this will have acute angle. And angle in minor segment, that is this. Okay, this will always have obtuse angle. Right? And if this chord is the diameter, then angle will be 90 degrees. We all know that, right? So, okay. So something like this, if it passes through the diameter, then it will subtend 90 degrees on both the sides. Right? Okay. So this was the thing, friends, which I wanted to share it with you. Okay. This will probably, not probably, this will definitely save your time during the examination. And in my opinion, time saved is nothing but the marks earned. Right? Okay. Right, friends? So as I said to you that I am going to make an important announcement. Okay. So friends, I see that a few of my subscribers are from northern part of India as well. Okay. From Bihar and UP and Madhya Pradesh, MP and all that. So for their benefit or for all of us, okay, whoever can understand Hindi, so whatever I have taught till date, that is mathematics, and I think another 2 chapters or 3 chapters is left. Number system is left, coordinate geometry is left, and then construction is left. Apart from that, everything has been done. Sorry, surface area and volume is left. Let me complete the surface area and volume. Okay, then the same whatever I have taught here in English will be available in Hindi, either on the same channel of same YouTube channel or on a different YouTube channel. I'll just upload the videos and then intimate. Right? Okay. So these videos, you my friends, you will be able to watch in Hindi as well after some time. Let me complete in English and then I'll start it up in Hindi. Right, friends? So this is all from me for today. So I close the session here. So this completes the chapter circle in all respects. There is nothing left. Nothing can be asked beyond this. Right? Okay. So with this we close it. Right, friends? So till the time we meet next, be happy, be safe. Keep learning with us. Stay tuned with us. Definitely we will add value to your life. Thank you so much. God bless you all.